All right, today we're going to talk about multiple representations of functions, section 9.1. For the most part, today should look very familiar because we did something very similar to this back in chapter 2 with respect to like scatter plots. If you remember doing scatter plots, if you remember writing equations of lines with trend lines of scatter plots, very similar today. Okay. You can use a representation of a function to create a different representation of the same function. For example, the table shows the cost of renting mountain bikes for 5 days at Outdoor Biker from 1999-2005. So you can use a table to represent functions. You can use the table to create a graph. Well, the graph is another way to express a function. And then beyond that, you can write an equation to express the function as well. So there are 3 different ways that you can use to express functions. Tables a lot of times are given to you. You can find them, just X, Y, plug in T-charts. We've done T-charts before, those type of things. Graphing, again, same thing, use the table to graph. And then from both of those, you can find the equation. The key to finding equations is you have to find the slope. So anytime you have to find the slope, you use 2 points. And again, you get to choose the 2 points. They can be 2 consecutive points. They can be 2 far away points. It doesn't matter. You choose the 2 points. And then once you have the slope, you plug it in just like we did in our warm-up into point slope form, changing it to slope intercept form. The only new thing they're really adding, different than what we did in chapter 3, was we can do a predictor. So we can predict the cost of renting a mountain bike in 2007. Well, to do that, I realized the years down here, if you look at my years, those are my x-axis, or my x values. So I take 2007, plug it in for x, and I solve. And that's what gets me approximately the cost of a mountain bike in 2007. All right. Again, that looks like, man, that's a lot going on there. It's really not that bad. The hardest part is finding the slope and plugging it into the equation. Okay. So number 1 here. The table shows the cost of renting ocean kayaks for a week at Ocean Adventures. Use the table to solve. Use the data to create a graph. So number 1 says use the data to create the graph. So I'm going to plot the coordinates. Now if I look down here, my year, those are my what coordinates? Those are my x coordinates. And the cost, that would be my y coordinates. Okay. So 1992, 28. Okay, I plot my coordinates here. There's 1992, 28. 1996, 42, I plot the coordinates. 2056, I plot. And 2004 and 70, and I plot. So I have my coordinates there, and I'm going to connect the dots. This kind of shows where it's going. Okay, and I can kind of, if I wanted to extend it, I can see, well, it's probably going to keep going that way. We all agree on that. It's going up. All right. So next thing here, that's the first part. I create the graph. Second part is I need to write the equation. Well, to write the equation, I first need to find the slope. Who remembers what the slope formula is? Anybody? That is slope intercept form. We will go there.
Minus x2 minus x1. No, that's y minus y1 equals slope and x1 minus x2.
Close. Slope formula. y2 minus y. We spelled that. Minus y1 over x2 minus x1. You did. You put x's on top, though.
Yeah, John did.
y2 minus y1 over x2 minus x1. So I need to find 2 coordinates here to find the slope. Which 2 coordinates would you like to use, Andy?
2004, 7.
And what other coordinate?
And 2056.
Awesome. So I'm going to use those 2 coordinates, and I'm going to find the slope. Now remember, it is y2 minus y1. So that means I'm going to have 70 minus 56 over 2004 minus 2000. And then I simplify. 70 minus 56 is
14.
2004 minus 2000 is 14 over 4 equals 7 over 2 or 3.5. So either way you could write it. You could go 7.5 or 7 over 2 or 3.5. That is my slope. Is everybody good so far? Okay. Next, now I need to write an equation. Well, to write an equation, I plug it into point slope form. Usually always the most popular. So point slope form, remember, is y minus y1 equals m parentheses x, parentheses, not equals, parentheses x minus x1. So y minus y1 equals m parentheses x minus x1. What coordinate would you like to use, Maddie? I need one of those coordinates over there.
Let's do 2056.
I like it. So I'm going to use that coordinate, and I'm going to use my slope, and I'm going to plug it into point slope form. So plugging into point slope form gets me y minus 56 equals 3.5 parentheses x minus 2,000. Okay. Now that I have it into point slope form, I'm going to change it to slope intercept form. What are the two things you got to do to change point slope form to slope intercept? You have to
Solve for, or distribute and solve for y.
Yep, I'm just going to distribute and solve for y. So I distribute, and then I add the 56 to the other side. So 3.5 times x is 3.5x. 3.5 times 2,000, 7,000. So negative 7,000 plus 56, so 7,000 minus 56 essentially gets me
6,044.
then 6,944.
Yeah.
And that's the equation of my line. And then number 3, last part. This is kind of the new part. It says predict the cost of renting a kayak in 2006. I have the year 2006. Remember, my years represent my what values? X. So I'm going to take 2006, I'm going to plug it in for X. So take 2006, plug it in for X. So that gets me y equals 3.5 times 2006 minus 6,944. So with the calculator, if you got one, 2006 times 3.5 minus 6,944. And now as you look at your graph, you should probably go, well, I can say approximately it's got to be about maybe around 80, right? Okay. Because if you look at your graph, you should know it probably shouldn't be about 40. It can't be down here, right? That's too low for that graph. It can't be way up here. Our graph's not matching that. Okay. So what does it actually come out to be? 77. And then we're talking about dollars. And if you look at my graph, yeah, it looks to cross about right at 77 right there. So that is perfect for our graph. Nice job. Let's try another one here. A bicyclist leaves the rest stop at, I think we're going to say that's 1 o'clock. We're going to say 1 o'clock there. And heads directly home at a constant rate. The table shows how far D he is from home in miles as a function of time t. Create a graph and an equation to predict the time he will arrive home. So as I look at my graph down here, time in minutes is my what value? X. So time is my X value. And then the distance is my Y values. So I need to now plot this on a graph. So 1 o'clock would be our what value here? Because I'm starting at 0 minutes, right? So I start when I leave, I'm at 0 minutes. It's like when you start a race. You start at 0 seconds or 0 minutes, wherever you're at. So 0, 18.5. So I plot my coordinate there. And then I go 10 more minutes. Because from 1 to 110, that's 10 minutes. And I'm at 16 now. And then I go 10 more minutes, and I go 13.5. And then I go another 10. Oh, that's a little low. And then I go another. Oh, that's really low. I gotta fix that one. That's better. Then I go another 10 minutes, and I get 11. And then I go another 10 minutes, and I get 8.5. Okay. Now, what do you tell me about my graph? Where's it going? What's that mean about my slope? If my graph's going down, my slope is negative. That is important to remember that. Okay, if the graph's going down, my slope is negative. Now I have to find my slope. I need to write the equation. Remember, slope formula is m equals y2 minus y1 over x2 minus x1. Now I need to choose two coordinates. You can choose any of the coordinates. I have 5 of them to choose from. Which two are probably the best to choose?
The first one and the last one. First one, second, first one. Base one, second.
I like you. Which one?
Second, third.
Andy says second and third. John said.
I said multiple seconds.
John said the first and the fifth.
Second.
And now Andy says the second and the third one.
So the bottom two are.
I personally like the second and the third one. Why do I like the second and third ones?
Because it'll kind of speak for you.
Because they're straight up numbers without decimals. Does that make sense? The decimals is 0.
Oh,
you said third.
I thought you were just like, okay.
They're talking about 13.5 and 16. I was like, what?
No, yeah. So the second, oh sorry, I did say second and third one, didn't I? The second and the fourth one, the one circled right
There
here,
you go.
those would probably be the better ones just because, well, I don't have like a 0.5 in there. It just makes it easier. You get to choose it. John, the first and the fifth one would have been a great one because 18.5 minus 8.5 would have been 10, right? You can see that. Again, just find ones that are compatible, easy to use for that. So I need to plug in my graph here. So I would get m equals 11 minus 16 over 30 minus 10, because those are minutes that are passed, right? 130 and 110, 30 minus 10. Negative 5 over 20, which is, my slope is negative 1/4. Awesome. Now I need to plug that into point slope form. And again, point slope form, y minus y1 equals m parentheses x minus x1.
Second one.
Let's choose the second one. I like it. So I'm going to choose that second coordinate, and I'm going to plug that in. Now again, instead of 110, I'm going to use 10 minutes, right? Because that's the coordinate we plotted right there. So I have y minus 16 equals negative 1/4 parentheses x minus 10.
So, negative 1/4 x plus 2.5.
Yep. So I have distribute here, right?
18.5.
So I get y equals negative 1/4 x. Is it plus 18.5, right?
Yeah.
I did 18.5, is that right? So there's my equation. We found the equation, great. Now, here comes the tough part. I got to answer that question here. It says, predict the time he will arrive home. What am I trying to find? I'm trying to find the time. So I need to plug in a distance here. At what distance are you home? We're going down. Does everybody see we're going down?
He's on that 0.
At 0. So now here's the question though. What do I plug 0 in for? Because I'm talking about my distance. My distance is 0. So I plug my distance in for y. So I'm going to plug 0 in for y. Nice job. So I get 0 equals negative 1/4. I'm just going to change that to negative 0.25 if that's all right with you guys.
Negative 18.5.
Plus 18.5. So now I need to solve for x. So I'm going to subtract 18.5, right? So I get negative 18.5 equals negative 0.25x. So I divide them. Now negative divided by negative would get me a positive, right? And if I look, as I look at my graph, it's kind of going down here. You can kind of get a pretty good idea of where it should be, do you not?
That's 7.4.
Yeah, what?
7.4.
I got close.
7.4?
Like, I don't know what I'm doing.
So you want to do 18.5 divided by 0.25. 74. You should get about 74 minutes.
It's there.
Again, think about that going down, right? As it's going down there, we see it should probably be between about 70 and 80 there approximately. And I think if you got a wrong answer, you might have multiplied them. So you would have done negative 18.5 divided by negative 1 or 0.25. Then again, negative divided by negative is a positive, so you could have done 18.5 divided by 0.25 and get the same answer. Okay, good work. All right, this one here. Number 6. New members at a fitness club paid $200 to start and then $20 per month for life. Create a table, a graph, and an equation that represent the total cost of enrollment C as a function of months M. So we have to kind of create a table here. Well, let's think about this here. Just, in real life here. If I join the fitness club for 1 month, So I go 1 month here. What's my cost going to be for that 1 month? You pay $200 to start and then $20 per month. 220. So all I do here is I just kind of think about this real life. I pick some months, plug it in. Let's say I go 2 months. What's my cost now? Let's say I go 3 months. My cost is, using that information right there, find or graph that and then write the equation of the line. Okay, so on your own, take a couple seconds, graph that and write the equation of the line. So as you're working this, I'm going to put the graphs on there. So 1 about 220. 2 about 240. And 3 about 260. Now if you wanted to, you could have done bigger values, kind of spaced it all more. What did you get for your slope, Jack? What did you get for your slope?
-20.
Positive or negative?
Negative.
Where's my graph going? My graph's going,
Oh, okay, so I messed up.
so it needs to be positive
I
20,
put-
right?
I just put a negative in my final.
And then that's kind of a self-check there. Think about it. If your graph's going up, it's always got to be a
Right.
positive. If graph's going down, it's got to be negative. Okay, what's my equation then going to be, John?
I just kind of wrote down plus 20x.
What?
Stopped. I just kind of wrote I forgot to actually do the equation.
Yeah, you need to put it in point slope form, right? So what is it then, Andy?
It is
Y equals 20x plus 200.
Y equals 20x plus 200.
I just wrote that down.
Yep, and you would have to choose either a point slope or even think about it. Let's say you were for 0 months, you're always going to pay that $200 flat fee right away. That kind of makes sense, right? 0 months is that $200. That's perfect. And then I could plug in. Let's say I wanted to say, oh, how about a whole year? What if I wanted to find out what a year membership was? Well, if I wanted to find out what a year membership was, how many months is that? 12?
I don't know, I think it's 8.
So I plug in 12 then. I'm going to plug 12 in for what value? Plug 12 in for X. And I can figure out how much that would be, or how much that cost for a whole year. Anybody know what that'd be?
Well, 240, so 440, right?
What'd you say it was?
440.
440. Nice job. Be $440. Good work. All right. Try number 5. Try number 5 all on your own here. Plot the graph and then find the equation of the line. I'm going to start writing the points up here. So you get 1 and 38, 2 and 46, 3 and 54, 4 and 62, 5 and 70, and 6 and 78. So my graph is going up, means my slope should be positive. What does my slope come out to be, Maddie?
Y equals 8x plus 62.
So my slope is 8.
Yeah.
Great. And then my equation, though, I want to plug it into point slope form. And my equation is what, John?
9, right? Y equals 8x plus 37.
Y equals 8x plus what? Should be y equals 8x plus 30.
Wait, what am I doing wrong? Because you plug in.
So what point did you pick, Maddie?
I picked 246.
Okay, so I plug it in. I get y minus 46
Oh, I forgot to.
equals 8 parentheses x minus 2. Distribute the 8. So I get y minus 46 equals 8x minus 16. And then you add the 46.
Minus 16 because I thought it was a negative 8.
Oh, so you added them. Is that what you did?
Yeah.
Gotcha. Yep, should be minus 16 plus 46. And that's what gives me y equals 8x plus 30. And then let's say I wanted to find out what your balance was after, let's go 10 months. If I wanted to find out my balance was after 10 months right here, I would plug 10 in for X. I get $110. Nice job. And that's it today. There's your assignment.